Dear Professor, I would like to submit my homework to Sharp number 1 about design a fuzzy logic controller by multiplying non-matrix triangular membership functions. First, I will introduce the fuzzy. Fuzzy means not clear, wait, not not clear, and bird. Not clear and bird, which means it can be applied to choose complex systems successfully, whose mathematic formulation is not clear or well defined. In our left, in our left, I often say halt, cold, or slow down or fast. Because if we said I feel hot, but you can mean you can know me is I feel hot, uh, but you don't. I hold the temperature. How much is the temperature I feel? Maybe uh, the temperature is 26 uh, degree, but somebody feel cold and somebody feel hot. And if we take a car or take a bus, uh, somebody feel it's fast and somebody feel it's very slow. So we this the fast, the host, the core, or the slowdown is some letters for us is mean. I feel it's fuzzy. The fuzzy logic controller intends homing sync to process and make discussion on this fuzzy information. Next, look, this is a fuzzy logic controller and use or to make the variable. The variable from the input a variable and process the fuzzy logic controller and we can got the output variable. Look, the fuzzy logic controller have three main processes. One is fuzzy fiction. It's mean that convert, converting input process quantities such as temperature or pressure or velocity and so on. Use these quantities into membership value in a sub-fuzzy set. For example, converting the actual measured temperature value into membership difference of fuzzy language variables such as cold, uh, moderate, and hot is to enable to controller to handle homing language like fuzzy information. For the second process is raw innovation is inference engine and the raw base. It means is raw evolution, reasoning based on a preset fuzzy controller or control rules. use like often use like if then the language, such as if the temperature is null or the temperature change rate is negative, then increase the heating power. Like this, use the if and then language. Determine the corresponding control strategy strategy by matching the input fuzzy quality and performing logic operations. For the third, also is final process is defusification. Defusification. It means the current the fuzzy output obtained through real evaluation into precise control output, which is used to drive actors such as motors to control the controlled object. For example, the temperature control of an air conditioner. When we feel that the room is a little hot, the air condi- condi- conditioner conditioner doesn't need to actually all know how much the temperature has risen, but instead adjust the cooling power appropriately based on the further information of a little hot. If it's very hot, increase the cooling force, which is a simple application of fuzzy logic controllers in process. Now, like this, the figure is block diagram of a fuzzy logic system. Before before they design the non-multiply non-metric fuzzy logic controller, we set the E, EC, and U. E is mean is represents the error, and EC is mean represents the rate of change of the error, and U is the control output. The two The two input variables "E" and "EC" are falsified by their respective fuzzy sets. The falsified inputs are returned through fuzzy rules. The final fuzzy is U. Final fuzzy output is obtained by the falsification process to get a specific output value. Next, now, now I will focus on design a fuzzy logic controller use a six multi- six multiply six matrix triangular membership function and say special steps. The first the first step is to define the input and the output variable. Next, look at this. The input, for example, I will take the temperature control system for an example. In the temperature control system, the input variables are temperature error and the error rate, or is E or delta E, as well the rate of change of error and the output value is the control signal. Use U use U to uh, to uh, to heating or cooling equipment. Next, look this. There have six variables. They are they are they all they are the input variables. The VNB is mean very negative big. The NM is mean negative minimum. The ZE is mean zero error, and the PM is mean positive measure, and the VPB is very positive big. NB is negative big. NS is mean negative small. PS positive 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 small, and PB is mean positive big. We can use the non variables to for the control input variable control variable, and use this. We can set for this temperature, determine the range of variable values like this. It's the determine the range of variable values for the temperature error in like this. E is from the -10 to 10. The delta E is mean error rate is from -5 to 5. And the control signal U is from 0 to 100. Next is set the E for the non-variable. For the VNB is -10, -10, and -8. For the NB is -10, -8, -6. The NM is -8, -6, -4. And the NS is -6, -4, and -2. ZE is -4 and 0 and 4. For the PS is 6 is 2, 4, 6. PM is 4, 6, and 8. PB is 6, 8, 10, and VPB is 8, 10, 10. Like this. This is range, and we can set the parameters for here. This is a figure of all figures. We can say it set the A for each one and set the delta E for this. Like this. The VNB is -5, -5, and -4. For the NB is like this, -5, -4, and -3. The NM is -4, -3, and -2. Like this. And the last one is VPN is 4, 5, and 5. For the U, we can set this because the range is 0 to 100. We can set the VNB is 0, 0, 10. NB is 0, 10, 20. For this, the last one is VPB is 90 and 100 and 100. 90, 100, and 100. Like this. Follow through set the E, delta E, and the U. Like this. The non-variables and set combined. We can got this diagram. The E is here, the delta E is here, and the middlemost is whole for you, is for you. Okay, this this diagram, it can be used for subsequent fuzzy rule formulation, fuzzy inference, and fuzzy resolution operation to achieve control of system. And next, look at this. This is for the MATLAB simulation. I said we can build this control rule, and we got build the fuzzy rule library like this. We can change the VMB, the ZE, and connect the VMB, MB, PS, and so on. This is E, here is E, here is delta E, and here is U. The fuzzy rule library, how to build like this from this diagram. We can use VMB, and the VMB we can quote the U is VPP. The E is MB, and the delta E is also is MB. We can quote the VPB. We can quote this and build for the non multiply non the fuzzy rule library. Next, we connect the view to the up, the down list. We can choose the surface to to generate a 3D surface map that shows the relationship between two input variables and one output variable. For the x axis and y axis represent input variables, and z the z variable the z axis represent output variable. Color the coding display different output value regions. Next, we can click the view and from choose the rule from the uh, down list. To get a general to this rule view interface, which allow user to view and edit the rule of the fuzzy logic system. We can choose the from here there is E, delta E, and the U. We can got the rules, the fuzzy rules. And next, we can dephasing from the Simulink. We use the Simulink of the MATLAB to design this circuit diagram, which consists of a temperature change signal represented by a sin 1 and a target temperature signal represented by a fixed value of 15. 50. We can use there is fuzzy logic controller. We can use the sin 1 and the scope, the display, and this scope. And this is the fuzzy logic controller of metonym. This figure I got from the Simulink. Uh, we can click the click here and here, like this. The here have a, a figure. We can click two. I got from there. Got this. Got this. The temperature arrow and other inputs are processed by a fuzzy logic controller module. Two output controller signals reflects the relationship between temperature arrow, temperature change rate, and the control signals. Finally, we obtained their waveform diagram like this. From from the comparison of data, we can see it's without the fuzzy logic controller. The temperature fluctu- fluctuation is larger because its control method is single. After after adding uh, a fuzzy logic controller, temperature uh, fluctuation will uh, significant, significant, will significantly reduced, a- able to be uh, maintained within a more stable range, and energy energy consumption was also reduced, achieving more e- effi- efficient, e- if, efficient, achieve more efficient and accurate control. Okay, this is our introduction of homework to sharp number one about design a fuzzy logic controller by non-multiply non-matrix triangular membership functions. Thank you, sir.